everyone, let's get into our math lesson today. Just like every math lesson, I need you to open up your math notebook, open up to a new page, put today's date on the top right hand corner. Today is the 11th/19, 2020. Let's get right into it. Go ahead and start with your warm-up and fluency. Put number 1. Try to solve. When you're ready, unpause the video and we'll go over it together. Okay, so number 1, we have a multi-digit number multiplied by a single digit. We're going to start with the ones place. That's all we have, so we're just going to do 8 times 6. And 8 times 6 is 48. So you put the 8 in the ones place, the plus 4 up here. Then you're going to do 8 times 4, which is 32, plus 4 is 36. Then put the 3 up here. And then 8 times 3, which is 24, plus 3 is 27. So your final answer is 2,768. Go ahead and solve number 2, and when you are ready, you're going to unpause the video. Okay, let's go over number 2. If we rewrite this problem, we're going to line up the place values. We are doing a double-digit multiplication by double digit, so I like to use my different colors. Start in the ones place. 4 times 6 is 24. 4 goes in the ones place, plus 2 goes above the 5. 4 times 5 is 20, plus 2 is 22. We're now on to the tens place, so I'm going to cross everything else that has to do with the ones. Put that 0 when you multiply the tens. 3 times 6 is 18. You put the 8 down here. Carry the plus 1. 3 times 5 is 15. Plus 1 is 16, which goes down here. Add them all up to get the product. 4 plus 0 is 4. 8 plus 2 is 10. Carry the 1. 6 plus 2 is 8. Plus 1 is 9. And then 1 plus nothing is 1. So your answer is 1,904. Let's go ahead and move on to our problem solving. So let me read it, and while I read it, you are to kind of listen, and then you are going to write down what you know and try to figure out if you can solve it. So Elliot B has 342 Pokemon cards. Lucas has 179 Pokemon cards. How many more Pokemon cards does Elliot B have than Lucas? That would probably be helpful if I could squeeze the whole problem on there. So let me read it again. Elliot B has 342 Pokemon cards. Lucas has 179 Pokemon cards. How many more Pokemon cards does Elliot B have than Lucas? So right now, I want you to try to solve it and pause the video. When you're ready, press play. Okay, first I'm going to highlight the numbers I'm working with. I'm working with 342, 179. Then I'm going to look for that math action word. What words are going to help me decide what type of problem this is? I'm going to underline the how many more. And then Elliot B has than Lucas. That's going to tell me that this is a subtraction problem, because we're looking at the difference. What is the difference between Elliot B's and Lucas's Pokemon cards? So I'm going to do 342 minus 179 and solve. So I wanted to make sure we were reviewing subtraction and regrouping, because I know it can be scary or a little difficult. So I'm looking at 2 minus 9. I cannot take 9 away from 2, so I have to go to my next door neighbor and take a 10. This 4 is now a 3. The 2 now becomes a 12, because you're going to add that 10 on. 12 minus 9 is 4. 3. Let me get my eraser. It's 3. Then you have 3 minus 7. You can't do that. You have to go next door again, take away 100. So that would now be a 2. Your 3 becomes a 13. 13 minus 7 is 6. 2 minus 1 is 1. So your answer is 163. 3 more Pokemon cards. Remember, that label is super important. Be really specific with that. And there you go. There's your final answer. If you're confused or have questions, please email me. But I wanted to make sure we were still not forgetting about our subtraction. Let's go ahead and learn about what we're doing today. So your objective today. So right down here, I'm going to highlight it for you. Objective. Mathematicians will understand and apply the distributive property of multiplication. So we've been working with a lot of properties of multiplication. We had our commutative property, which is no matter the order of the factors, you'll still get the same answer. Then we had associative property, where it was no matter the grouping of the factors, you'll get the same answer. So that's like when we had 3 times 5 times 2. And you wanted to group the factors. Let's say we grouped 5 and 2 together. 5 times 2 is 10 times 3, so this equals 30. Or you could have done 3 times 5 is 15. 15 times 2 is 30. So no matter how you grouped the factors, you got the same answer. And today, now we're going to do distributive property. First, we're going to start with a little brainstorming to get our brains thinking about distributive property. We need to first know, what does distribute even mean? So I want you to think to yourself, write this word distribute down in your notebook. Go ahead and take the next 30 seconds to either draw a picture or to write a definition. So pause the video. When you think you have an answer, you're going to press play and hear what distribute means. Okay, so distribute, it means to pass out. So if we means to pass out or to give out. So it's like sharing something. So if I draw a picture, let's say I'm going to distribute the independent practice to all of us, all the students. My picture would look like this. I have the paper and I'm going to give it to this student, I'm going to give it to this student, and I'm going to go over here and give it to this student. So I'm giving it out to each person, and I drew that picture to kind of show you what that means. And I'm doing this because when we talk about the distributive property, you're also going to be showing what you're sharing or giving to the other numbers. So today we are getting right into the distributive property, and this is the definition that we need to write in our math notebooks. So, distributive property. It lets you multiply a sum by multiplying each add-in separately and then add the products up. We should probably kind of break that up even further, because if we don't know what some of these words mean, just like when we've been practicing with nonfiction, it's going to be really hard to understand the definition. So here are some vocab words that we see in the definition. We see the word sum. We should know by now that sum is the answer to an addition problem. We see the word add-in. Add-in is a number which is added to another. Just the numbers in an addition problem. Just like factors are the numbers in a multiplication problem, add-ins are numbers in an addition problem. Then, of course, we have the word product, which we know is the answer to a multiplication problem. This is a really hard definition to understand. I think it's easier to visually see what distributive property is. So go ahead, pause it, get this all down if I'm going too fast, but I'm going to move on to an example. So we have 7 times 12. Yes, I know some of us just know it right off the top of our heads, but I want to show you how to solve it with the distributive property. Now, the distributive property is all about decomposing, taking apart a number to make it two easier numbers. So right here, I want to decompose or take apart the number 12 into two easier numbers. 12 can be separated into 10 and 2 because 10 plus 2 equals 12. Now, all I did there was I looked at the number 12, I looked at each place value. How many ones are in the tens place? 1, so it's 110. How many twos are in the ones place? 2, or how many numbers are in the ones place? 2, so you have 2 ones. So that's how I got the two numbers, 10 and 2. And now what I would do, this is what it's going to look like for distributive property. I still bring down that 7 times, and remember yesterday we introduced parentheses. I'm going to do parentheses 10 plus 2, parentheses. Now I know this looks a little crazy right now, but let me show you where drawing arrows really come in handy. So the add-ins are 10 and 2, and the factor, there's 7 right here. You're going to take 7 and you're going to multiply it by 10, and you're going to take 7 and you're going to multiply it by 2. So if we break it down even further, if we rewrite it, oops, we don't want that 0. There we go. We're going to do 7 times 10. Leave those in parentheses so you know what you're grouping together. Plus, we can't forget that addition, 7 times 2. And just like yesterday, we talked about doing whatever's in the parentheses first. So 7 times 10 is 70. 7 times 2 is 14. And then we're going to bring down the addition problem. So then our last step is just taking 70 plus 14. 4 plus 0 is 4. 7 plus 1 is 8. So your answer is 84. Now you're probably wondering, why did we do the distributive property for 7 times 12 when that is just an easy math fact that we should know? Well, when numbers get harder and bigger, the distributive property really helps us break it down. So let's do another example so you understand what I mean by this. Let's do the number or the multiplication problem, 6 times 15. Now, yes, you could always do the traditional method, but today, since we're focusing on distributive property, we're not going to do that. We're going to separate out the number 15. So I want you to look at 15 and think of the numbers that you could separate it out into to get 15. Remember, just look at the tens place. How many tens do you have? You have 1, 10. How many ones do you have? You have 5 ones. So those are the two numbers you would separate 15 out into. So then, to rewrite the equation, you would do 6 times, parentheses, 10 plus 5, parentheses. Draw those arrows. You're going to do 6 times 10, then 6 times 5. So when we're grouping them together, it'd be 6 times 10 plus, because you can't forget the addition sign, 6 times 5. Do what's in the parentheses first. 6 times 10 is 60. 6 times 5 is 30. Add them together, and you get, if you needed to do traditional, or you can just think 6 plus 3 is 9, and then 0. Your answer is 90. Now, if we wanted to do traditional to double check our work, I'm okay with that. 6 times 5 is 30, carry the 3. 6 times 1 is 6, plus 3 is 9. So right there you can see that you're going to get the same answer, but I want us to use and know what the distributive property is for multiplication. So let's do another problem. This time I want you guys to try to set it up like this, so make sure all of this is in your math notebook. I want you to try to set up the exact same way and see how far you can get with it before you get frustrated. Once you get frustrated, just press play and see after I do it if you can do it. So 9 times 13. We're not doing traditional. You can double check with traditional, but I want you to separate it out with distributive property. So go ahead, pause the video, try to decompose the number, try to work through it, and then once you get frustrated, press play. Okay, the first thing you should ask yourself is, what number are we going to decompose or take apart? You always want to take apart the bigger number so you can make it into easier numbers to multiply by. So the bigger number here is 13. When you look at 13, you're asking yourself, what are the two numbers to make 13? How many tens do I have? I have 1 10. How many ones do I have? I have 3 ones. So that's how you find the two numbers that make up 13. That will be making an easier multiplication problem for you. Now the next step, you're going to ask yourself, how do I write this equation? Well, you still start with 9 times. Then you're going to group together the 10 and the 3 using parentheses, and you make it an addition problem. So that is your equation. Now you're going to distribute the 9, or multiply the 9. We're going to do that by drawing those arrows. 9 is going to multiply by 10, 9 is going to multiply by 3. We're going to rewrite it again, grouping with the parentheses. 9 times 10 plus 9 times 3, because that's all we're doing. We're just taking the answer to this problem and we're going to add it to this answer of this multiplication problem to find the product. So 9 times 10 is 90, 9 times 3 is 27, and we're going to add those together. And you can do traditional method. You might be even able to do this in your head. 0 plus 7 is 7, 9 plus 2 is 11, so your final answer is 117. We can always double check with traditional method to see if we set it up correctly. 9 times 3 is 27, carry the 2. 9 times 1 is 9, plus 2 is 11. So I'm okay with you double checking your work with traditional, but I really want you to show your work just like this to get to the final answer, because that's distributive property, and we need to know what distributive property is in 4th grade. Let's do one more, and this is going to be on your own. Try your best to do it on your own and see how you can do. So we have 5 times, now we're going to do 21. First thing you want to ask, what number are you going to decompose or take apart? And then you're going to ask yourself, how do I take it apart? I look at the tens and then I look at the ones. So go ahead now, try it on your own. When you finish, press play so we can go over it together. Okay, let's go over this one together. It's a little trickier, but I wanted to end on a high note and see how we did. So 21 is the bigger number, meaning we're going to decompose 21. If we rewrite 21 over here, you're going to separate it out. You're looking at the tens place. How many tens do I have? I have 2 tens this time because there's a 2 in the tens place. How many ones do I have? I only have 1 1. So now I'm going to set up my distributive property equation, which is 5 times, in parentheses, 20 plus 1, parentheses. I'm going to distribute the 5, meaning I'm just going to multiply the 5 by both numbers and rewrite it out. So I'm going to do 5 times 20 plus 5 times 1. Then I'm going to do what's in the parentheses. 5 times 20. Use your zeros rule, where you cross off the 0 and you do 5 times 2, which is 10, and append the 0 at the end. Then you're going to add it with 5 times 1, which is 5, and that's an easy addition problem. 100 plus 5 is 105. Once again, if you wanted to double check with traditional, you're going to do 21 times 5. 5 times 1 is 5. 5 times 2 is 10. So that's what you're going to be doing on your own. Once again, if you need help, ask a neighbor, email me. I'll send out another video if we need it. But hopefully we can try and persevere and problem solve to do the distributive property. Now we do this because it's easier to kind of dissect or decompose a number and make it into easier multiplication problems and then adding the products up to get the final product. So try your best. I know some of us are going to love to just stick with traditional method, but as 4th grade and as 4th graders, we need to know how to do distributive property. So good luck, work hard, and you'll be just fine.